Okay, so first thing we're going to do is, this is the third day in our unit on how wind and ocean currents and everything affects the climate. So first let's read our essential questions for the day. So they're right on this, if you could read that one for me, Mason.
Okay. How is oceanic circulation affected by uneven heating? And how do convection currents determine climate?
Okay, so let's talk a bit about some of the vocabulary that we recognize from these words. We haven't talked about oceanic circulation yet, but what can you infer about those words, what that might refer to? Do we know what circulation is? Have you heard that word used somewhere else before? And with what? So water. Like what is circulation described about water? Like the movement? Okay. And so, so the movement, and then oceanic, what does that probably refer to? Yeah. It sounds just like it. Good. And another word we want to review is convection. We'll talk about in a little while. The word currents. What do you know about the word current? Like in regards to the earth.
Like when something's currently happening, it's like present.
Yeah, that's one definition of the word current. Have you heard the word current used in reference to water? Have you heard it used that way? What does it mean when it talks about water? Waves or tides? Okay. That's a good understanding to start with. And the last key word I want to look at is the word climate. That's one I know you've studied in past years and this year. What does the word climate refer to? What do you remember? Weather? Do you remember in, what was it, 5th or 6th grade learning about the biomes? Yeah, exactly. Very good. Okay, so now what I want you to do, you're going to think, pair, share about density. So think to yourself, and then I want each of you to explain to the other what your understanding of the word density is from our previous days we studied it. So whoever wants can go first. It's okay if you're not 100% sure. What do you remember about density that we've done?
I remember that if the density is greater than 1, it'll sink in water.
Okay. Good, you remember the formula. Very good. And now, what did we learn about the density of water? I mean, you said the density of water is typically 1. What did we learn in our unit about hot and cold water? Okay, and we saw in our labs how colder water will sink below the hot water, it's a little less dense. Okay, very good. So now, before we kind of get into our lesson, I want you to make a prediction. So we're looking at our map, and we know that currents is some kind of movement in the ocean of water. And we've talked a bit about different temperatures of water and how which is more dense. What do you think, we'll make a prediction about what affects the climate of the world. Based on this knowledge, based on past knowledge, what determines the climates of each place? Make a prediction.
The equator.
Oh, the equator? And what do you know about the equator here?
It's warmer than the
Okay. Is there anything else you think affects the climates in different areas? The oceans do? Okay. Oh, so certain oceans are colder and some are warmer? That's a good prediction. Any by the end, our goal is for you together to be able to write a paragraph to describe how the ocean specifically affects climate. Okay. So, first, we're going to kind of work together with the map. And then we'll watch our video that kind of gives us the rundown of how currents do affect climate and how they work. And then we'll come back to our map to kind of practice, make some predictions of different climates, and then get into our written piece. Okay. So what I'd like you to do first, we have our whole world map here, and we have some cubes. We've got red cubes for hot water and blue cubes for cold water. And what I'd like you to do, I want you to create some currents on the map. So we know a current might look like, it's the movement of the water. I just want you to kind of play with the cubes and make some currents where you think, oh, there might be a warm current here, maybe there's a cold current here, however you see fit. So that between the two of you, go for it. This is your prediction time. Doesn't have to be right. Yep, use all the cubes.
Like by the end of the lesson, will we be able to tell?
Yes,
which are colder and which are warmer?
Yes, I will show you the kind of the major current that we're looking at. You do whatever you like. I'm not going to tell you yet, if you're right or wrong. Because if you were making a current through the world, what temperature, what might you think it would be?
Warmer.
Oh, I see the one nuclear.
Mm-hmm.
Just let me know when you think you're done placing the cubes.
Yeah, I think so.
Okay, so I see a bit of a pattern here that you have the hot water kind of centered and then the cold towards the tops. Now, what made you decide to put the cubes where you did? What about your knowledge about the world?
It's warmer towards the equator.
Mhm.
Colder temperatures.
Mhm.
Lower.
It's probably cold here.
Yeah, you've learned that it's pretty much all ice. Okay, that's good predictions. Very good. Okay, so now let's take our knowledge of density of water based on temperature. How might you think the temperature of water could cause ocean currents to move? Because we've seen how the cold water will sink below the hot water. What do you think? How do you think that might affect currents?
Like where it's cooler, there might be more current because it's dense.
Okay. Makes sense, sure. What about an area where there's warm water? Maybe it's a stronger current?
I think this cold one would be stronger.
You think cold water would have stronger currents? Why is that? Can you expand on that? Tell me more.
Because it's more dense.
I think it'll be still because it'll probably just hit center.
Oh, so you don't agree with each other. That's okay. We'll figure out exactly what happens. It's just that both of your predictions make sense, and I'm really happy to see you using kind of creating a rough claim and then providing evidence based on what you know. That's perfect. Okay. So I think we are ready to view this video. It's about 4 minutes. It gives a good overview. It does talk about some vocabulary terms we're not going to get into this year, but it really does a good job telling us what the current would look like and how it would move. So I'll start that up. Hopefully the volume works just fine.
I spy with my little eye something that's blue. Yep, the ocean. You win again. This game is getting kind of boring. Hey, a message in a bottle. Dear Tim and Moby, my mom said you might get this message if I put it in the ocean. How can this happen? From Vivian. Vivian, does your mom know that we got shipwrecked? And that we've been drifting around aimlessly for a week? Please, tell your mom to call the Coast Guard. I'm extremely hungry out here. What do you mean she doesn't know? She's asking about ocean currents? Alright. The waters of the world's oceans are always on the move. Ocean currents help ships, animals, and bottles move around the globe. The ocean can be thousands of meters deep, but surface currents only affect the uppermost 100 or 200 meters of water. Fortunately, I brought my map of ocean surface currents with me. If you look closely, you'll see that the currents actually move in large circular patterns called gyres, and each gyre is bordered by one or more continents. Surface currents are mainly caused by wind. You might not know this, but some winds blow across the ocean in the same direction all year round. The rotation of the Earth causes the winds to deflect off to the right in the northern hemisphere and deflect off to the left in the southern hemisphere. This is called the Coriolis effect. That makes gyres rotate clockwise above the equator and counterclockwise below it. Surface currents have a major effect on climate and weather conditions. If you look at the map, you'll see that Paris, France is at about the same latitude as Montreal, Canada. But winters in Paris are a heck of a lot nicer than winters in Montreal. Parisians can thank a current called the Gulf Stream for that. It delivers warm water from the tropics to Western Europe. In the North Atlantic, the Gulf Stream radiates heat into the atmosphere. That's why the winters are warmer in France. Currents can make for colder climates too. Hawaii is located in the tropics, but its climate is slightly cooler than other tropical locations since the California current brings cool water south. Yeah, it'd be nice if we drifted ashore in Hawaii. Anyway, deep beneath the ocean's surface, there's another current system. It's not powered by wind at all, but by temperature and density. Remember the Gulf Stream? What are you talking about? I just described it like 30 seconds ago. Well, like I said, in the North Atlantic, the warm waters of the Gulf Stream radiate heat into the atmosphere. This loss of energy causes the water to cool off until it's almost freezing. Cold water is denser than warm water, so the surface water soon begins sinking. Millions of liters of water sink in the North Atlantic every day, but they can't just pile up there. They have to flow somewhere else. So when the cold water gets 2 or 3 kilometers down, it starts moving south. It flows all the way to Antarctica, then starts flowing north again. In the Pacific, the water starts warming up and returns to the surface. It flows back into the Atlantic Ocean, where it joins up once again with the Gulf Stream. And once the Gulf Stream waters reach the North Atlantic, they lose heat and sink, and the whole process starts over again. Because this current system loops all the way around the globe, it's sometimes called the global conveyor belt. The belt moves very slowly. It can take 1,000 years for water to make the full circuit around the Earth. Land! Moby, we're saved! Woo! We made it! Oh, drat.
Alright. And I'm going to just kind of freeze it on that last picture. You can see.
Heat and sink.
Okay. So, do you recall the two different kinds? Or I should say two different ways currents are caused. They talked first about, we're not going to go into it too much here, probably later, about how wind does affect the surface currents of the ocean, making them rotate in certain ways and then affecting the climate. But what we're really focusing on today is the deeper oceanic currents, what really affects them. So what was it that really...
The winds.
Yeah, the world spinning is part of it. And what else affects the movement of the ocean current?
Oh, density.
So we saw it explained with this picture of the current moving, and the blue is like our blue squares and the red. What is that image demonstrating to us?
Where the currents move.
And what causes them to move like that?
They get more dense, they sink. They go around.
Very good. Okay, so what I'd like us to do now is to go to that sheet there with the map on it. I'm going to give you a couple of markers. And actually first, I'll switch this. Create that current map for me on this big map, and then I'll have you create it for yourselves on your smaller map. So take that image and use the cubes to kind of recreate what that would look like. Yeah, you can make it look like kind of swoop downward. Like the blue there, it goes down right touching Antarctica. Yeah, it's a little tough because the cubes are bigger. See how the blue touches Antarctica? There we go. That's pretty good. Okay. So this, of course, represents, one of the most major ocean currents in the world. The Gulf Stream being here, flowing in all the way around. And of course, there are other currents going on elsewhere, as you saw on the map, but this is one of the most major ones. So, what I'd like you to do now is to now take the markers and create that same kind of current pattern on your own map, the colored one right in front of you. You can do dots, dashes, whatever you like. to do next, I have a series of pictures here of just kind of, different climates. You can kind of infer what type of climate based on what you see in the picture. And I want you to place these on this map based on your knowledge about different climates of the world, as well as thinking of the way these currents form and how we've talked about how they affect climate. So you just work together and make a prediction where they would be. I think that makes sense. So I'd like you to select one and explain to us, kind of defend your thinking, why you feel that climate might go there, and especially try to connect it to what you know about ocean currents.
Should I go?
Sure.
So I put this one here because the ocean currents are, it's warmer close to Africa and it's cooler close to this region.
Okay.
And since this looks like droughty,
Mhm.
it's a lot warmer.
That makes perfect sense. Now, is that why you put these two here? Because they're greener. You put that one there. Why did you select to put that one there? Mhm. Like, why might this one make more sense here? I mean, they're almost at the same same place here. Why might that one make more sense here, but these two would make more sense in South America? Okay, and what about this ocean current pattern you see here might affect that?
It's kind of warm.
It's warmer here, it's colder.
Okay, so it's a little cooler. I think you both did a really nice job making these predictions about where these images might go. Okay, so let's review our key vocabulary together, and then we'll get to your paragraph. So our first vocabulary word is density. And we talked about the formula we remember, which is density equals,
Mass divided by volume.
yes, so you can put that in your formula for density. And what kind of definition do you think we should put for ocean currents? You know, simplest words.
Different temperatures of water moving.
You can even go simpler than that. But even just to say, like, you know, ocean water is moving. Because, yeah, that would work perfect. You took it to kind of the next step. Okay, now convection currents. Have you heard the word convection before? In regards to what? You heard of a convection oven before? Mm-hmm. Yes, very good. It kind of rotates air through the oven so it cooks more evenly.
Is this about the wind?
It is to do with the wind, and well, even more so the heating, because we know that, you know, heat affects the wind patterns, and we also know that heat affects the patterns of the deeper waters. So you're kind of imagining you have your surface currents, the wind's affecting the way they move, and then the wind and the heat, I should say, and then the heat also of the lower water is affecting it moving in a circular motion. So convection currents has to do with heat making the water move. And you kind of said that earlier with this definition. But the convection piece has more to do with how heat makes water move.
That's one we can.
Yeah. It also applies to air, but for this map, we're really focusing on the water movement. All right. And come up, please, with a definition for climate. That's a review.
Like the different.
Yeah, perfect. Yeah, say biomes, weather, whatever would be best for you to remember it by. Okay, so we have our definitions, we have our current map and this, and I even gave you some clues with this color-coded map to help about, you know, what the different climates are like. You can kind of see how the ocean currents.
So like tropical, but it's more dense.
Yes, it's a little cooler there. Yeah, and you have your arid, it means really
Tropical,
dry.
wet and dry is kind of like right here where it's cool currents and warm currents.
Yeah, very good. So what I want you to do now is to look at this page here with your sentence starters to help you with your paragraph. So Aiden, will you read the essential question?
Describe ocean currents that affect climate.
Okay. So I'll read all the supporting questions and then you'll get your paragraph. Well, sentence starters. First, ocean currents are, tell me what they are. They're caused by, how they affect the climate, and then another reason how they affect the climate, and then taking these 4 sentences or 4 ideas, creating a complete paragraph.
Okay.
Okay?
So then after reading these, we kind of just combine.
Yes. And you can work together, that's fine. Or you can do it by yourself.
Do we have to rewrite this?
No, you could do that more as like notes, or those are just, yeah, to get you started. Whatever works for you. I'm happy with.
Ocean currents.
sharing your paragraph before we wrap up?
Sure.
Thank you.
Ocean currents are moving water that passes through the world. Ocean currents are caused by density and wind. Currents affect the climate by the temperature of the currents. Ocean currents can also affect the Earth's climates by passing through different biomes.
Nice. Okay. All right. Do some good work. I think you have a good starting understanding of how these ocean currents work, and we will keep building on it.